All right, so this is the last problem, and I'll do 53 as well. Last problem that you need to do for homework number 25. This says find the series representation of the function and determine its interval of convergence. So for this one, I think we might have had something similar to this in the notes. Remember, we do have a series for 1 over 1 minus x. We know this. 1 over 1 minus x is our geometric series that we memorized. Its a value is 1 and its r is x. So this is just x to the n. So how is 1 over 1 minus x related to 1 over 1 minus x squared? They are related in that they're derivatives. So this f of x is the derivative of 1 over 1 minus x. We can check that. 1 over 1 minus x is like 1 minus x to the negative 1. So see if we get to 1 over 1 minus x squared. So take the derivative of this. It would be negative 1 minus x to the negative 2. And then remember, you have to chain rule. The derivative of 1 minus x is negative 1. So yeah, that is equal to positive 1 over 1 minus x squared. So what that tells me is I can come up with this power series by taking the derivative of this power series. So 1 over 1 minus x squared should be equal to the derivative of the power series for 1 over 1 minus x. So taking the derivative of that power series. So that comes out to, I'm going to wait on my n equals, that comes out to n times x to the n minus 1. Now, I can't have n equals 0 here because that would give me x to the negative 1. And if you're not sure on this, list out some, like, what are the terms for this original series here? It's 1 plus x squared plus x cubed, etc. What about when you take the derivative of that? What are those terms going to need to be? That becomes 0. This becomes 1. This becomes 2x plus 3x squared, etc. So when I take the derivative, the first term should just be 1. It shouldn't be something over x. So if I start this at 1, I will get 1 times x to the 0. And then if I plug in 2, I get 2 times x to the first. So see how this series matches up with what the terms should be. So if you're having trouble writing the series, expand out the terms of the original series, take derivatives of those terms to see what you should be getting, and then adjust your n accordingly. All right, so this is the series, and determine its interval of convergence. So I'm going to use, because there's another n out here, I'm going to use the ratio test. The limit as n approaches infinity of the absolute value of n plus 1 times x to the n plus 1 minus 1, so x to the n, over the nth term, n times x to the n minus 1. So the n's are going to be approaching 1. When you subtract these exponents, n minus 1 is 1. So you're going to get 1 times x. So that's going to come out to the absolute value of x. And this converges by ratio test if the absolute value of x is less than 1, which means that x should just sit between negative 1 and positive 1. Check the endpoints. If I check the endpoints, let's see. If x equals negative 1, what would this series be? I'm testing into this one. So from 1 to infinity, this would become n times negative 1 to the n minus 1. That is alternating, but the terms are not decreasing. This is not a bottom-heavy expression, so that diverges by nth term test. And I think the same thing will happen if x is 1, but I'm still going to write it down, just pretending that I'm doing this for like a free response question. So yeah, if I plug in 1, I'm still going to get something that just is not approaching 0. So this diverges by the nth term test. So the interval of convergence is officially between negative 1 and 1, but not including either of those endpoints. Now, I did say to skip 53. I'll just do it because I have it here and I posted it on my answer key. So the reason I wanted you to skip it is because I think it says find the sum of the convergent series by using a well-known function. Well, I would have you do this if I at least gave you what the well-known function is. So here's what we're going to be. Let's say we're given this because they're claiming that it's well-known. So the natural log of x plus 1. Maybe we've done this in a homework somewhere. I can't remember. The natural log of x plus 1 has this power series. It's the sum from 1 to infinity of negative 1 to the n plus 1 times x to the n over n. All right, so I'm doing the work of, or I've done the work of finding that for you, and the interval of convergence for this is between 1 and negative 1, only including positive 1. So this is just our given thing. So let's say you knew that going into this. So find the sum of this series. Well, remember, with series, the only series that we know how to find a sum for is geometric or telescoping. But this extra little caveat here is if we know that this series has an interval of convergence that includes our sum here, then we can just plug into f of x. So like, for example, if I know that this series is just this series evaluated at some number between negative 1 and 1, I can just say, oh, well, the sum of the series will match whatever ln of that value is. Okay, so let's take a look at the series. It's got the negative 1 to the n plus 1 that this has. It has a 1 over n that this has. And then this 1 over 2n, if you look at that, this is just saying, let me rewrite this series a little bit. This is just saying we have a 1/2 to the n that's being divided by n. So see how I've got it in the same form here? The x here is 1/2. And 1/2 is in our interval of convergence. So what is the sum of this series? The sum of this infinite series is equal to ln of 1/2 plus 1. So it's equal to the ln of 3/2. We don't need to plug that into a calculator. We could plug it into a calculator, but I know this. It says explain how you obtained the sum. I know this is true because the sum of the power series with x values, I'm going to say this, with x values in the interval of convergence are exactly equal to the function at that x value. So I could change this out and say, okay, what is the sum when x is 1? And I would have a sum for that because I would just say, oh, it's ln 2, 1 plus 1. What's the sum when x is negative 1? I don't know that answer because negative 1 is not included in the interval of convergence. So I can answer what the sum of this series is for any number between negative 1 and up to and including positive 1, but nothing outside of that range. All right, we are going to be practicing some AP problems coming up. So hopefully all of this practice in the homework, some of this will look familiar or we'll get to apply it as we go into AP free response questions.